Good. So we can start the new topic, right?
Yes.
And deformation, the worksheet you sent, this one
Yes.
and the pressure one, both we'll discuss together. Huh?
Okay, sir.
Now, if we do this notes, then we can you will be able to solve the worksheet. That's why it is better to discuss the notes today. Okay,
Yes.
you will at least have some work. So, can you read the learning outcomes? Pressure.
Define the term pressure in terms of force and area and do calculation using the equation pressure equals to force by area. Explain how pressure varies with force and area in context of everyday examples. Describe how the weight of a liquid column may be used to measure the atmospheric pressure. Explain quantitatively how the pressure beneath the liquid surface changes with the depth and density of the liquid in appropriate examples. Recall and use the equation for hydrostatic pressure P equals to rho gh. Describe the use of manometer in the measurement of pressure difference. Describe and explain the transmission of pressure in hydraulic press with the hydraulic systems with particular reference to the hydraulic press and hydraulic brakes on vehicles. Describe how a change in volume or fixed mass of a gas at constant temperature is caused by a change in pressure applied to the gas. Recall and use uh, T1 and V1 equals to P2.
Okay, so here you got some of the ideas what already you have, right?
Yes,
That pressure equals already you finished because you are in class 10. That's why you know all the things from pressure. And here only we are going to link
yes,
one thing with another. Here we have the pressure formula. Pressure equals force by area. And using this formula, we are having this everyday examples. How force and area in the context of everyday examples, we are getting benefits, right? Like knives.
yes,
If it has smaller, it's more sharp, then it has more smaller surface area. And then you have more pressure, right?
yes,
The nails. So here we are getting the benefits from smaller surface area, and if we have bigger surface area, that time also we are getting some benefits like ice skating, right? uh,
yes, sir.
skiing on the ice, not ice skating, skiing on the ice, right?
Yes,
Skiing on the ice, we are having more surface area, then we are not sinking in the snow, right?
yes,
And we have big tires of the trucks, right, or lorries,
yes,
and more number of tires. We are increasing the surface area so that the trucks and lorries, they can move easily on the road. This way we have lots of examples. Using the larger surface area, we are getting benefits. We are having a small pressure, right?
yes,
And then we have the formula, another one. We have P equals rho GH, right? Here G is
yes,
always constant. So uh, rho is also constant for the same liquid. So if the depth of the liquid or the height of the liquid is more, then pressure will be more, right? This one we got here, and this learning outcome here, C and D, both are related to this formula. And atmospheric pressure is the pressure from the atmosphere or the air pressure, right? The more higher place we are going, the atmospheric pressure is less. If you are going to mountain, then atmospheric pressure is less. And if you are going to sea level, atmospheric pressure is most, right? Because always we are having the
Yes, sir.
pressure calculated from the height from the lower surface to the upper. What is the height of the air column? That one is our concern. If the air column has more height, then it has more pressure, because more, if you are thinking about your house, in your room, on the table, from the roof or the top of your ceiling, right? That ceiling, from the ceiling till to the table, the air column you have, the from the ceiling to the floor, your air column is more, right? Isn't it? Do you understand what I'm saying?
Yes, sir.
So, where will be the atmospheric pressure more, on the table or on the ground?
Uh, on the ground.
Yes, yes, you are right. So on the ground it is more because the air column is more there. Similar way it's working on the mountain and on the sea level. On the mountain, if you are thinking from the where the atmosphere starts, from the top place to the mountain, the air column we have, the air column till to the sea level is more. That's why on the sea level the air pressure is more. So till here we have this much discussion. And atmospheric pressure, there is one instrument to measure atmospheric pressure, and that is barometer. And we have mercury barometer here. We are going there. Before that we are discussing little bit, and how mercury barometer is working we will show. Then we have another instrument, that is manometer, where we are measuring the gas pressure. Yeah. And there also we use different kinds of liquids to measure the pressure, right? Like we can use the mercury, we can use other liquids also. Mostly we are using mercury. Then we have hydraulic press and hydraulic brakes. That one I will show you in diagram how it's working using this formula. Using the first formula, we are using hydraulic brakes, hydraulic press, and getting the benefits. Then we have the relationship of pressure and volume, right?
Yes.
If if you think that temperature is constant, then pressure is directly proportional to 1 by V, or you can say inversely proportional to V, right?
Yes, sir.
So this one is coming here, PV equals constant, so P1 V1 equals P2 V2. That means if you increase the volume, then pressure will be less, right?
Yes,
And
sir.
if you decrease the volume, the pressure will be more, yeah, at constant temperature. Now we are going through the notes. Have a look there. At the beginning, you see we have P equals F by A, and our formula is force by area. So the unit is Newton per meter square. In short, we can also say Pascal, right?
Yes, sir.
And here you have one numerical. This is very easy numerical. You can do it. Hydrostatic pressure or liquid pressure. You see, everywhere the height is same. That's why the pressure is same of the liquid. Huh?
Yes, sir.
Whatever the shape of the container, if it is same liquid, then the pressure will be same. Here it is more clear. The more depth, the pressure will be more, right?
Yes.
Here at P3, the pressure is more. You see, P3 is greater than P2 is greater than P naught. Pressure at point A we are having the container open. So here atmospheric pressure is also working. Along with that one, we are having liquid pressure. So our total pressure is P naught plus rho gh. P naught here is the atmospheric pressure. Do you understand what I'm saying? Hello.
Yes, sir.
So here we showed how this formula came. P equals rho gh. How it came. The explanation is there. If you just see, you can understand it. Just you see atmospheric pressure, lower pressure at the higher place, higher pressure at the lower place. We are showing here how it is working. Liquid, the air column is more here, that's why pressure is more. Here the air column is less, that's why pressure is less. And labeling is also there, you understand it. Now it is mercury barometer. Mercury barometer here, we are having the atmospheric pressure on this surface, right?
Yes, sir.
So if you are having more atmospheric pressure, that means it will push the liquid and more liquid go inside the tube. Uh,
Yes.
then you'll have more reading inside the tube, uh, and we can say atmospheric pressure is more. Got it?
Yes, sir.
Yeah. And if the atmospheric pressure is less, then liquid level here rises outside of the bowl.
Yes,
Here
sir.
liquid level rises and here it drops. Here is more. The one I told just now is here. Explanation. And atmospheric pressure is how it is 1.013 into 10 to the 5. The calculation is here.
Yes, sir.
Yeah, you have 76 centimeter mercury. If you convert to meter, 0.760 meter, then density of the mercury. So rho gh multiplied by 10, 9.8. If you calculate, it comes 1.013 10 to the power 5. This way, we are getting the atmospheric pressure value. Here again, we are having because of the height of the, from the height of the mercury, we can understand why the atmospheric pressure is more. That example
Yes,
just now we discussed. Now manometer, is a new thing for you. Uh, is measuring the gas pressure, right? So this side is
yes,
open and this side is closed, and this from this side we are having the gas pressure. Uh, so if you are having gas pressure here, you are pushing it, the liquid you are pushing.
sir. Can you
If,
zoom in a little?
sorry?
Can you zoom in a little? It is the reading is small.
Okay, okay. Is it coming now?
Yes, yes. Now it's clear.
Okay, look, if both the sides are open, then what will happen? The liquid level will be equal, right?
Yes,
There will be no difference in the liquid level. Now, if you are giving pressure from this side, from the gas, the liquid level rises here. So, you are working against the atmospheric pressure, right?
yes,
And that's why we are having the atmospheric pressure plus this liquid pressure added to get the gas pressure, right?
yes.
So gas pressure is P minus P naught. So gas pressure
Mm.
here we are getting P minus P naught equals rho gh. Here we have more points. Can you read this bullet points?
The simplest of such instrument is a U-tube containing some liquid, usually mercury, water, or oil, The pressure exerted by a confined gas changes the levels of the mercury in a manometer. The total pressure of a gas or liquid is the total pressure it exerts in the effect of atmospheric pressure.
Hmm. Continue.
Changes to liquid in manometer. When the manometer is not connected to any gas supply, the liquid levels in the left and right side of the, there are equal since the atmospheric pressure acts on both surface of the liquid. When one end of the tube is connected to a gas supply, the pressure exerted by the gas changes the levels of the mercury of column. If
So
the
just
gas
now I told you this one, right?
Yes,
That how it is working. So all these things, whatever I discuss is here, right? So
yes,
gas pressure equals atmospheric pressure plus pressure of mercury column, right? This way it
yes,
is coming. Yeah? Is it clear?
yes, sir.
And if the gas pressure is smaller, then we are having this formula. P, P gas equals atmospheric pressure minus pressure of mercury. Is it clear to you?
Yes, sir.
Like if you are, what is the explanation of this? Like if your gas pressure is that much that your atmospheric pressure is more, then what will happen? The liquid level will rise this side, left side, right? That time we are having that minus equation. That means the atmospheric pressure is more than the gas pressure. Now it is happening that gas pressure is more than the atmospheric pressure. So we are adding P naught plus H rho g, right? If the gas pressure is less than the atmospheric pressure, then we are subtracting P naught minus H, rho g H. Is it clear?
Yes, sir.
So and now we are having hydraulic systems. I told you that here we are using the formula P equals F by A. Now I am showing you how it's working. You see, it's a hydraulic car lift, right?
Yes,
This is for maintenance of the car or the washing of the car we are using. So how it's working? Look, we have this formula P equals F by A, right?
yes,
Here, if you are having P equals F by A, then for example, here we are giving force 5 Newton. The area we are getting 1, huh? 1 1 meter square. Then what is the pressure?
5.
Pressure is 5 and 5 Pascal we can say, right?
Yes,
This side the pressure will be also same 5 Pascal. Pressure remains constant both the sides as the pressure is applied to the liquid.
yes,
Okay, now what happens? This side we are having larger surface area. For example, here the surface area is 5.
yes,
We are having the surface area here 5. We are having the force how much? The formula is still like that. P equals F by A, right?
yes. Then it will be 15.
So, what is the force here we are getting?
25.
25.
Yes,
So, this is the work, yeah, work of hydraulic lift, 25 Newton, right?
yes,
So, this is the principle of working of hydraulic brake also, hydraulic brake and the hydraulic press, all these things. So you are clear, right? How it is working?
Yes.
All these things are discussed here. No? Same way, the hydraulic press, hydraulic brakes are working. We are applying here less force. We are
Yes.
getting here greater force
Huh.
in the brake. Okay.
Yes, sir.
Then the last one is Boyle's law, the one just I told you.
Hmm.
If you apply more pressure, the volume is less.
Yes.
End of topic, right? You can solve the worksheet.
Yes.
Thank you so much. Do the worksheet and send me by Saturday.
Okay, sir.
Okay?
Hmm. Allah Hafiz.
I already